Light travels in straight line path, but this concept is not as much straight as you think. Shadows are always not completely dark, and sometimes they are not sharp at edge. They are blurred there. And also light shows some strange phenomena and different type of patterns. So what are the concept behind all these things? Today in this lecture, we are going to discuss about all those things. So without a further ado, let's get started. इस लेक्चर से पहले आप लाइट और उससे रिलेटेड कई सारे कंसेप्ट को पढ़ चुके हैं, बट बिफोर स्टार्टिंग ए डीप डिस्कशन ऑन लाइट वी मस्ट नो about light. Light is a form of energy which travels from one point to another point. How it travels? In 17th century, Huygens told about the nature of light which is responsible for its movement from one point to another point. According to Huygens, light travels from one point to another point due to its wave nature. Before continuing discussion on this, let's talk about waves. What are waves and how they travel from one point to another point? आप यहाँ पे देख सकते हैं, जैसे ही एक वाटर ड्रॉप स्टेबल वाटर सरफेस के अंदर फॉल करती है तो यहाँ पे अप एंड डाउन मूवमेंट हो रही है, एंड आल्सो दीज मूवमेंट्स आर मूविंग इन फॉरवर्ड डायरेक्शन. दिस टाइप ऑफ पैटर्न इज नोन एज वेव. And this type of wave which is moving in forward direction and vibrations, or you can say movements, are perpendicular to this. It is moving in this direction, but movements are perpendicular to the direction of propagation. So this type of waves are known as transverse wave. Light waves are also of same nature. They are transverse waves in which vibrations are perpendicular to the direction of propagation. Now let's talk about the amplitude and frequency of these waves. You are watching here, water is going up and down. If I change the amplitude is how much it moves up and down from the level surface. If I increase the amplitude, it is moving more upward direction and downward direction, means its displacement is more from the mean surface. If amplitude is small, then it moves smaller displacement. So this is the amplitude. How much is the displacement from its mean position is the displacement of that. Now let's talk about the frequency of these waves. You can see here number of up and downs, that is amplitude, changing amplitude is going on increasing and decreasing, depends upon the frequency. As the water drops, if more drops are occurring in the same time, then you observe more waves are produced. If less number of drops are falling in this, you observe that less number of waves are produced. This is known as frequency. So frequency is a number of vibrations or variations occurring in this per second. So amplitude is displacement of the wave perpendicular to the direction of propagation, and frequency is a number of vibrations occurring per second. If we see these waves from upper side, you can observe this type of pattern. Now these type of patterns are known as wave fronts. The concept of wave front can easily be understood by this type of pattern. You can see a lots of number of particles are there which are vibrating in the same phase or in the same circle. Some are in upper side and some are in down side. So some upper side are in same phase, down sides are in another phase. So all the particles in these circles are in same phase. So these particles are known as wave fronts. Here are the particles. If we consider such points, some imaginary points inside a wave, and if we join all these imaginary points, then the pattern which we obtain is known as wave front. If we want to define this, we can easily define that locus of all those points which are vibrating in same phase. जो particles एक ही phase में vibrate कर रहे हैं, उन सब का locus लोकस मीन्स हम उनको अगर इमेजनरी टाइप से मिला दिया जाए तो जो पैटर्न हमें मिलता है वो वेव फ्रंट होता है। अब वेव और वेव फ्रंट के बीच का थोड़ा सा कंसेप्ट समझ लें। वेव, जब कोई भी वेव इस तरीके से चलती है वो, और फ्रंट जो सामने से दिखाई देगी, जो वेव का पैटर्न हमें दिखाई देगा, दैट इज नोन एज वेव फ्रंट। तो इसी तरीके का वेव फ्रंट ऑब्जर्व होते हैं इन केस ऑफ लाइट वेव्स आल्सो। Since source of light are not same, so the wave fronts are also not same. For a point source of light, the wave front is spherical in nature because from a point source, light travels in all directions. And we know that waves produced at equal distances from the central point are in same phase. If we imagine some points at that waves and if we join them, then we observe a spherical wavefront. A point source of light produces a spherical wavefront. Now what about a linear source of light? A linear source of light produces cylindrical wavefront because from linear source light travels in all directions, but it is in linear in nature, so it forms a cylindrical wavefront. And now a third type of wavefront is also there, and that type of wavefront is known as plane wavefront. Then how this plane wavefront is obtained? अगर हम इसमें से किसी भी वेवफ्रंट को, चाहे वो स्फीरिकल नेचर का है चाहे वो सिलेंड्रिकल नेचर का है, उसका हम एक बड़ा सरफेस बना दें तो उस बड़े सरफेस के छोटे से हिस्से को हम प्लेन मान सकते हैं। जैसे आप अर्थ के ऊपर खड़े हैं, आपको आपके आसपास का एरिया जो अर्थ का सरफेस है वो प्लेन दिखाई देता है। क्यों? क्योंकि हम थोड़े हिस्से को ही ऑब्जर्व कर पा रहे हैं। बट इफ वी मूव आउटसाइड द अर्थ, देन अर्थ इज elliptical in nature. We knows this very well. Same thing happens with these also. यहाँ पे भी हम अगर किसी भी वेव फ्रंट के, बड़े से वेव फ्रंट के एक छोटे से हिस्से को लेंगे तो वो वेव फ्रंट एक प्लेन वेव फ्रंट के तरीके से काम करेगा। So this plane wave front can be obtained from cylindrical as well as spherical wave front. And we know that for a distant source of light, rays are parallel to each other, and these rays produced a plane wave front. अब यहाँ पे एक कंसेप्ट आपको ध्यान रखना है, वो ये कि जो वेव फ्रंट है, अभी हमने ऑब्जर्व किया कि वेव जिस डायरेक्शन में बनती थी, वेव फ्रंट उससे परपेंडिकुलर डायरेक्शन में है। सो वेव फ्रंट इज ऑलवेज परपेंडिकुलर टू द रेज ऑफ लाइट। These wave fronts can be converged or diverged with the help of a convex and concave lens, and also with the help of prism we can deviate them through some angle. Now let's come back to our discussion on wave nature of light. The first thing for wave propagation is a medium. To travel wave from one point to another point, medium is necessary. Light is reaching us from sun, and there is no medium between earth and sun. Vacuum is there, but for propagation of light, medium is required. Then how these waves are moving from sun to us? Huygens in 17th century explained this phenomena with the help of a virtual medium which is presently all over the world, all over the universe. That is ether. It is a hypothetical medium which is present everywhere, but there is no proof of that ether is present everywhere. The medium Huygens considered for his theory is supposed to be highly elastic in nature. It is massless and is of very low density. In the support of his theory, he gives some points known as Huygens Principle. According to which every point on primary wavefront acts as a original source of light which travels with velocity of light in all directions. A surface touching those secondary wavelets tangentially in forward direction at any instant of time give the position of secondary wavefront at that instant. But the question arises here is that we know that on primary wavefront, the source of light, every point is the source of light and it emits light in all directions. Then why the wavefront in backward direction is discarded? Now let's try to understand this, why only wavefront in forward direction is taken and backward is discarded. One point is that energy flows in forward direction. It never flows in backward direction. So the wavefront of only forward direction is considered. And this can be proved mathematically. How? Let's see. As we know that intensity I, that is equal to 1 plus cos theta divided by 2. Here I is the transmitted intensity. As for backward direction, theta is 180 degree. This implies that I, that is equal to 1 plus cos of 180 divided by 2. And we know that for cos of 180 value is minus 1. So the answer for this will be 1 minus 1 is here divided by 2. Means 0 divided by 2. It is 0. And hence no intensity or no light is transmitted in backward direction. Now let's discuss reflection on the basis of wave theory, that is by Huygens construction. Consider a plane wavefront AB is incident on a plane mirror MM dash and which is reflected such that B A dash is equal to CT, where C is the velocity of light and A B dash is also equal to CT. Using the Huygens principle, now A dash B dash is the true wavefront, that is a secondary reflected wavefront, if that is dP plus PD dash is equal to BA dash. You can see this thing in this figure, that is dP plus PD dash is equal to BA dash. Now as PN is perpendicular on BA dash, so that this dP is equal to PD dash. PN is perpendicular on BA dash. Now dP is equal to Bn. We can write here that is dP, this is equal to Bn. Say this is a relation number 1. Now triangle A dash B and triangle A dash B dash are congruent triangles because BA dash is equal to AB dash, which is equal to CT, and angle B, that is equal to angle B dash, that is equal to 90 degree. In this diagram you can see here, and also A dash is common to both. Angle BA dash, that is equal to angle B dash A dash A. This implies that is angle I, that is equal to angle R. This is say equation number 2, which is law of reflection. As PN is parallel to AB in this diagram, then angle I is equal to angle alpha. This is say equation number 3. From 2 and 3 we get that is angle alpha is equal to angle R. Now in triangle P N A dash and another triangle that is P D dash A dash are congruent triangles because PA dash is common to both, as angle alpha is equal to angle R and angle N is equal to angle D dash. This is of 90 degree. So PD dash is equal to N A dash. This is say equation number 4. This implies that DP plus PD dash is equal to BN plus NA dash. You can see all these things from this diagram. DP plus PD dash, that is equal to BA dash, because BN plus NA dash, you can see from here, BN, this is the BN up to this point, plus NA dash is equal to BA dash from this point to this point. Thus A dash B dash is true reflected wavefront. Now from here laws of reflections are proved, that is angle I is equal to angle R, which is a first law of reflection, and the second law in which an incident wavefront AB, reflected wavefront A dash B dash, and reflecting surface M dash all are perpendicular to the plane of paper. Therefore incident ray, reflected ray and normal all lie in the same plane, which is second law of reflection. So using the Huygens principle, we can explain reflection on the basis of wave theory also. Now let us discuss refraction on the basis of wave theory, that is by Huygens construction. For that, let xy is a plane surface which separates a denser medium from a rarer medium, as shown here. Let this first medium, this is a rarer medium, I am using R for rarer medium, and velocity in this medium is say C1, and this is a second medium, and this medium is say denser. For denser I am using D, and the velocity in this denser medium is say C2. Now C1 is the velocity of light in first medium, that is in rarer medium, and C2 is the velocity of light in denser medium, say in medium 2. Now we know that refractive index, that is mu1 2, this is the ratio of the two speeds, that is C1 by C2. Let AB is plane wavefront incident on xy plane. These are the incident rays of light which are perpendicular to this plane. This A dash B dash is a refracted wavefront. This is a angle of incidence I, and this is angle of refraction, that is equal to R. According to Huygens principle, each point on primary wavefront acts as a source of secondary wavelets in all direction. The secondary wavelet at point A travels in a medium 2, so that distance traveled in time t, that is y, that is equal to c2 into t, and this distance is ab dash. This is the distance which is traveled by the wavelet from A in medium 2. But the secondary wavelet from point B travels in medium 1. So the distance traveled in time t from B to A dash is say x, and that will be equal to C1 t, and this is equal to A dash B. Now let this point is D and this central point is P. This is say D dash. Now A dash B dash is true refracted wavefront. If dP by C1, dP, this is dP and this is travel. Since this point is in medium 1 and in medium 1 velocity is C1, so we are dividing this by C1 plus PD dash for medium 2. So we use PD dash divided by C2, that is equal to BA dash, this one, and since it is traveling in medium 1 and in medium 1 velocity is C1, so this will be equal to BA dash divided by C1. Say this is equation number 1. Now draw PN perpendicular on this BA dash, this is say N, and therefore AB dash is equal to BN plus NA dash. PN is perpendicular on BA dash, therefore BA dash, that is equal to BN plus NA dash. We can use this. This implies that BA dash, that is equal to dP plus NA dash, because BN is equal to dP. You can see from here, that is BN is equal to dP. Now dividing this equation by C1 on both sides, we get, that is BA dash divided by C1 is equal to dP divided by C1 plus NA dash again divided by C1. This is say equation number 2. Now from 1 and 2, dP by C1 plus PD dash by C2, that is equal to dP by C1 plus NA dash by C1. These two cancels out each other, so that we left with, that is PD dash divided by NA dash, that is equal to C2 by C1. This is say equation number 3. In triangle ABA dash and P triangle PNA dash are similar triangles. Therefore AA dash divided by PA dash, that is equal to BA dash divided by NA dash. This is a relation number 4. Triangle AB dash A dash and triangle PD dash A dash are similar. So A dash divided by PA dash, that is equal to AB dash divided by P D dash. This is a relation number 5. So from relation 4 and 5 we get that is B A dash divided by N A dash, that is equal to A B dash divided by P D dash. Or we can write that is P D dash divided by N A dash, that is equal to A B dash divided by B A dash. This is equal to say that is C2 by T and this is C1 by T, as we can find from these relations. Thus, P D dash divided by N A dash, that is equal to C2 by C1. Hence, so from here, mathematically, we proved that this is the refracted, or we can say true refracted wave. Now, let us look at the laws of refraction. The first one, that is in triangle A dash B, sine I, that is equal to B A dash divided by A dash, which is equal to C1T divided by A dash. This is say equation A, and from triangle that is A dash B dash, that is sine R, this is equal to A B dash divided by A dash, and this is equal to C2T divided by A dash. This is say B. Now ratio of these two, that is sine I by sine R, that is equal to C1T divided by A dash multiplied by A dash, ऊपर की तरफ चला जाएगा C2T cancelling out A dash, we get C1 by C2, and which is equal to, we have calculated mu1 mu2, which is Snell's law, which is a first law of refraction. And the second one, incident ray, normal and a refracted ray all lie in the same plane. So from these we can prove two major laws of optics, that is reflection and refraction on the basis of Huygens construction. यहाँ तक हमने वेव नेचर ऑफ लाइट के बारे में जाना. वेल, अगर दो लाइट वेव्स को एक दूसरे के साथ मिक्स किया जाए या सुपर इम्पोज किया जाए तो क्या होगा? लेट्स डिस्कस दिस विद द हेल्प ऑफ सुपरपोजिशन principle. What is the superposition principle? When two or more waves of same nature are superimposed over each other, then a new wave is formed whose displacement at any instant is equal to vector sum of displacement of individual waves. If crest of one wave falls over the crest of another wave, then amplitude of a resultant wave will be the sum of the amplitudes of the individual wave. And when crest of one wave falls over the trough of another wave, this time the amplitude of a resultant wave will be the difference of the amplitudes of the individual wave. And the direction of amplitude will be in the direction of the wave which have a larger amplitude. So from here we can conclude that when crest of one wave falls on crest or trough on trough, then they makes a maximum amplitude of the resultant wave. And when crest of one wave falls on the trough of another wave, or trough falls on the crest of another wave, then the amplitude of resultant wave gives a minimum value. This type of superposition is destructive in nature. So from here we know that these waves are interfering with each other, and how they will interfere with each other and what type of waves will be observed we see in the next lecture. Till then, goodbye.